And welcome to our second lesson on angles and triangles. This one's angles in standard position in all quadrants. So yesterday we only did quadrant 1. So we had our initial arm here, and then our terminal arm, say, would be there. And you'll remember from yesterday, we'd turn that into a little right triangle, and we'd use that as our angle, so that would be opposite, that would be adjacent, and that would be our hypotenuse there. Well, notice that our opposite was always y, our adjacent was always x, and our hypotenuse was r yesterday. Well, we're going to continue that through all 4 quadrants. Cos, instead of being adjacent over hypotenuse, is going to be x over r, because that's what it was yesterday. Sine's y over r, and tan is y over x. Okay, so we're going to draw some more angles in standard position and find sine, cosine, tangent of those angles. I'm going to start with B over here because it's what we did yesterday. So B, we're going to have a terminal arm there. Or sorry, our initial arm is there. And then our terminal arm is going to be at 3, 4. So that's going to be 3 there, that's going to be 4 there. So there's a point on our terminal arm at 3, 4, which means that we're going to have that right triangle there. That's going to be 4, that's going to be 3. And now I'm going to use Pythagoras to figure out what r is. And r is going to be plus or minus 5. We're only going to take the positive one, so r is going to be 5. So let's replace our r with 5 there. So sine of theta, and remember theta's here. Sine of theta is going to be opposite over hypotenuse, or we can also think about it as y over r. Oops. Either way, it's going to be 4 over 5. Cosine theta, we can think of adjacent over hypotenuse, or x over r. That's going to be 3 over 5. And tan theta is going to be opposite over adjacent, or y over x, which is 4 over 3. Okay, so that's all the same as yesterday. Okay, now let's have a look at this guy, negative 3, 4. So our initial arm is always here, and this time we're going to have negative 3 there and 4 there. So there's our terminal arm, and there's our angle theta. Notice our angle theta is bigger than 90 degrees. Okay. And again, it's best to think of it as this being our triangle here. And if you want to, you can think about that as 4. That is negative 3. And our r is still going to be 5, because we're going to have the same calculations for r. Okay, so sine theta is going to be y over r, still 4 over 5. Cosine theta is going to be negative 3 over 5. And tan theta is going to be 4 over negative 3, which we can rewrite as negative 3 over 4 if we like. Okay, so notice that 2 out of the 3 of these are negative. Cosine theta is going to be negative, and tan theta is going to be negative. Okay, let's have a look at negative 3, negative 4. So it's going to be negative 3 here, negative 4 there. There's our point on our terminal arm. Our initial arm is always here. And notice this angle is going to be, angle theta is going to be bigger than 180. Again, we're going to draw our triangle in here. So it's going to be negative 4, that's going to be negative 3, that's going to be 5. So sine theta is going to equal negative 4 over 5. Oops. It's a horrible looking 5. That's better. Cos theta is going to be negative 3 over 5. tan theta is going to be negative 4 over negative 3, which of course just equals 4 over 3. And again, notice 2 out of the 3 of these are negative. Okay, and last guy, initial arm always here. This time our terminal arm is going to be at 3, negative 4. So there's our, did I say initial arm? Terminal arms. Going to go through 3, negative 4. And we always go counterclockwise, so we're going to have a really big angle here. There's our angle theta. Notice that's going to be bigger than 270. Again, we'll draw our triangle in here. So this is going to be negative 4. That's going to be 3, and that's going to be 5. So sine theta is going to be negative 4 over 5. Cos theta is going to be 3 over 5. And tan theta is going to be negative 4 over 3. And again, notice 2 of the 3 of these are negative. Okay, so other thing we should notice is that here sines 4 over 5, 4 over 5, negative 4 over 5, negative 4 over 5. So if we have kind of the same points, they're going to be the same. We'll talk more about that later. The main thing that's important now is, if we look in the first quadrant here, we can see that all 3 sine, cos, and tan are going to be positive. So all 3 are positive there. Over here in quadrant 2, only sine is positive. Down here in quadrant 3, only tan is positive. And over here in quadrant 4, only cosine is positive. Which leads us to a little memory trick on remembering this. So if you just draw out your quadrants, and you go, all students take calculus. Okay, so that says that in quadrant 1, all sine, cos, and tan are positive. Quadrant 2, only sine's positive. Quadrant 3, only tan's positive. And in quadrant 4, only cosine's positive. Okay, reference angle is very important. So here's our initial arm. And obviously here's our terminal arm down here. And you can see that circle with the dot, which is why we call that a radius. And now your reference angle, which we usually call alpha, is going to be the smallest angle between the terminal arm and the x-axis. So in this case, that's the smallest angle between the terminal arm and the x-axis right there. So our alpha equals 60 degrees, sorry. Okay, and let's just have a look down below and we'll see a few more examples of our reference angle alpha. Notice that for some reason your textbook says that the 300 degrees is alpha and the reference angle is theta. I recommend you just switch it to what we're doing here. This is more standard and it's just going to screw you up if you try to think about your reference angle is theta and your standard position angle is alpha. So again, here for number 2, let's start with part B. So we need to draw theta in standard position at 30 degrees. So there's my initial arm, and there's my terminal arm, and there's my 30 degrees. Notice I'm not that worried about how accurate this is. I'm not going to use a protractor. Okay, and now it wants us to find the reference angle alpha. So alpha in this case is the shortest angle between our terminal arm and the x-axis. Well, that's just going to be 30 degrees. Okay, and now theta is 30, so I'm going to punch sine 30 degrees in my calculator, even though in other cases you'll be expected to find the exact value for the exercise. You can just throw it into your calculator, and you're going to find out that sine 30 degrees equals 0.5. So that was for our theta, our angle in standard position. And then for our alpha is also 30. So of course sine 30 for that is also going to be, I'm trying to think of the best way to show this. colon. And then for our reference angle, sine 30 is also going to be 0.5. Okay, so notice in this case, sine of our standard position angle and sine of our reference angle are the same. Okay, let's have a look at part A. So there's my crosshairs, there's my initial arm, and 150, so that's going to be between 90 and 180, so that's going to be over here, and that's going to be 150 degrees there. Okay, well we can see that 180 minus 150 is going to give us 30 degrees in here. So my reference angle, alpha, is going to be 30 degrees again, like I designed it that way. Okay, and let's have a look at our standard position angle. So that's going to be sine of 150 degrees. Punch that into your calculator, and 0.5. And again, for alpha, our reference angle, sine of 30 degrees, we know is also 0.5. So in A and B, the sine of our reference angle and the sine of our angle in standard position are the same. Okay, let's have a look at part C. So our initial arm is always here. And then our terminal arm is going to be between 180 and 270. So it's going to be down there as 210. Okay, and we're going to want to see, oh, there's our, here, let's draw on our theta. There's our theta of 210. Might as well just label it as 210. And now my reference angle is going to be the shortest angle between the terminal arm and the y-axis. So it's going to be this angle in here. So I can go 210 minus 180 equals 30 degrees. So again, I've designed this so our reference angle is 30 degrees. So let's punch the sine of 210 into our calculators, and we get negative 0.5. And of course for alpha, it's still the sine of 30 degrees, which gives us 0.5. So this time, these two guys are the same, except for the signs are different. Okay, and last guy, 330 is going to be between 270 and 360, so he's going to be there. So there's my 330 degrees. And notice if I want to figure out my reference angle, shortest distance between the terminal arm and the x-axis, I can go 360 minus 330 is of course 30, because that's the whole point of this exercise. So again, for theta, I get sine of 330 equals negative 0.5. And for alpha, again, I get the sine of 30 equals 0.5. So the sine of my reference angle and my angle in standard position are the same, except for all students take calculus, and these bottom two, sine, are negative. So that's why I have that. So how are sine theta and sine alpha related? Well, they're always the same except for the sine. So if sine theta, so they're somewhat close to equal, except for sine alpha is always positive. So the absolute value of sine theta will give us sine alpha. Sometimes sine theta is positive, sometimes it's negative, but the magnitude of it will always be the same as sine alpha. Okay, so we're going to see how to use that on the next page. Okay, so part 4, we've got tan of 45 degrees equals 1, which we should have known from our special triangle. Remember, if I draw a triangle like that, that's 1, 1, that's 45 degrees, so opposite over adjacent is always going to be 1 over 1, or just 1. Okay, and let's start with part B on this guy. So I'm going to draw theta equals 45 degrees in standard position. So there's 45 degrees. So, done. Tan of 45 is 1. It's already told us that. So this guy's done. Okay, now tan 135. Okay, let's have a look at this guy. So 135 is going to be between 90 and 180. So there's our 135 degrees. And let's figure out our reference angles in there. So that's going to be 180 minus 135 gives us, not surprisingly, 45 degrees. Okay, so tan of 135 is going to be the same as tan 45, but maybe positive, maybe negative. The way we can figure that out is we go all students take calculus, and we see that in quadrant 2 only sine is positive because that's an S, which means that tan must be negative. So tan 135 must be negative 1 because it's the same as tan 45 except for whether or not it's positive or negative, because our reference angle theta is 45 degrees, or sorry, our reference angle alpha is 45 degrees. Okay, and C will do the same thing. There's our initial arm, 225 degrees. And this time I'm going to go 225 minus 180 equals 45 degrees. So again, our reference angle alpha equals 45 degrees, which means that tan of 225 has to equal tan 45, might be other than the sign, might be positive, might be negative. So T tells us tan is positive, so tan of 225 is 1. And one more of these. 315 will be between 270 and 360. Initial arm there. So there's 315 degrees there. And again, our reference angle will be in here, between the x-axis and the terminal arm. So if I go 360 minus 315, I find out again, not surprisingly, that our reference angle alpha equals 45 degrees. So tan of 315 is going to equal tan 45 except for the sign. C tells, oops, didn't mean to scribble that out, I meant to highlight it. C, cosine is the only thing that's positive in this quadrant, which means tan must be negative, so tan 315 must be negative 1. Okay, and there's just space for a quick summary down here. So all students take calculus. So sine is the only positive one here, tan is the only positive one in that quadrant, and cosine is the only positive one in that quadrant. Okay, so again, things to remember from this lesson: your reference angle is always the shortest angle between your terminal arm and the x-axis. Okay, emphasis on x-axis. Okay, and you also need to know this all students take calculus stuff to know whether or not your values of sine, cosine, and tangent will be positive or negative in each quadrant. Okay, and here's the first question from the textbook. So the point 2, negative 5, so it's going to be somewhere around there. There's 2, there's negative 5. There's P lies on the terminal arm. So we need to determine sine, cosine, and tangent of that angle there. We'll call it theta. Okay. Notice they use theta here as the angle in standard position, and then they switch it up later. Makes me mental. Anyways. Excuse me. So first thing we need to figure out is r. So r squared is going to be 2 squared plus negative 5 squared, or 5 squared, doesn't matter. So r squared is going to equal 4 plus 25 is 29. Square root both sides. R is going to equal plus or minus root 29, but we're going to throw out the negative because r can't be negative. So our r is going to be root 29. So sine of theta is going to be y over r, or negative 5 over root 29. Cos of theta is going to be x over r, 2 over root 29. And tan of theta is going to be y over x, or negative 5 over 2. Okay, so part B, I'm just going to do it here so we can still see the graph, wants to know the measure of angle theta. First thing you're probably going to notice is your calculator will never throw out an angle bigger than 270 degrees, which this is. So what we're going to have to first figure out is what our reference angle alpha is, and then once we have the reference angle alpha, then it'll be easy to just subtract that off of 360. Okay? So if tan theta equals negative 5 over 2, then our tan alpha will be the absolute value. Oops, that just wrote a theta again instead of an alpha. Tan of alpha, you remember, is the absolute value of tan theta, so that's just going to be a regular 5 over 2. So we can use our calculators to find out that tan alpha, or sorry, alpha is of course the inverse tan of 5 over 2 to the nearest degree is 68 degrees. So we now know that alpha up here equals 68 degrees. So theta is going to be 360 minus that 68 reference angle equals approximately 292 degrees. Okay, so notice that if they're asking you for an angle somewhere outside of quadrant 1, you're going to have to use the reference angle first and then figure out what the angle is by adding and subtracting 180 or 360 or something like that. Alright, and here's a final question from the textbook to end this marathon. So we need to determine the trig ratios of all the angles that have 60 degrees as a reference angle. Okay, so first thing we're going to do is, instead of looking at page 433, we're going to have a look at our 60 degree special triangle. Remember, it's an equilateral triangle, all sides 2, which means that all corners are 60 degrees. Then we're going to cut it in half. So that becomes 30 degrees. That becomes 1. And then we used Pythagoras to find out that that was root 3. So here's our diagram. So if this is going to be 60, that's going to go up to root 3 and over to 1, and my radius is going to be 2. And in this quadrant, if this is 60, then that's going to be negative 1. That's positive 1 there. And in the third quadrant, that'll be negative root 3. And in the fourth quadrant, that'll be 1 negative root 3, that point there. So for 60 degrees, the point on the terminal arm is going to be 1 root 3, which means that cos is going to be 1 over 2, sine is going to be root 3 over 2, and tan is going to be root 3 over 1, otherwise known as root 3. Okay, our next one, if that's 60, then theta must be 120, because it's 180 minus 60, so that's 120 degrees there. And that's going to go left, so negative 1, positive root 3, because it's still going up. So it's going to be negative a half, root 3 over 2, and negative root 3. Notice, as we learned before, these values are all going to be the same as we move down. The only thing that's going to change is whether or not they're positive or negative. Okay, down here, if that's 60, then all the way around is going to be 60 plus 180. That'll be 240 degrees. And this last guy here will be 360 minus that 60, so that guy will be 300 degrees. So let's put those two down here. So that's 240 degrees. That's going to be 300 degrees. 240, my terminal arm's at -1, -√3, which means I get -1/2, -√3 over 2, and +√3. And this guy's going to give me 1, -√3 is the point on the terminal arm. So cos is going to be 1/2, -√3 over 2, and this guy's just -√3. Okay, so notice the main reason we did this is you can use a diagram and your special triangles to get exact values for the sine, cosine, and tangent of 30 degrees, 45 degrees, and 60 degrees. Or sorry, for reference angles of 30, 45, and 60. Okay, so depending on which quadrant the terminal arm's in, your actual angle and standard position is going to change. But if your reference angles are 30, 60, or 45, then you can get exact values for sine, cos, and tan.